Hello, this is Salman Saif and he's my group member, Idris Khan. We have done our final project, classification of pulmonary sound as normal and abnormal breathing under supervision of Dr. Abdul Basir. Here are the contents of our project: introduction, problem statement, literature review, aims and objective, methodology, results and discussion, conclusion, and future recommendation, and references. First, we go through introduction. About 235 million people suffer from COPD, chronic obstructive pulmonary disease, worldwide, according to WHO, World Health Organization. In Pakistan, numbers are being projected to 6.9 million and will be the fourth leading cause of death by 2030. Several conventional methods still exist for pulmonary diagnosis. Researchers have been developed different techniques for analyzing the breathing sound behavior and diagnosing its abnormality. Machine learning is new innovative form of medical diagnosis, the practice of using technology to discriminate the conventional method of diagnosis. It is the approach towards more efficient diagnosis in medical field. The model classifies breathing sounds in binary categories, which are normal and abnormal breathings. Here are the problem statement and motivation. As far as diagnosis is concerned, traditional stethoscope is limited in its services. There are a range of possibilities of failure of stethoscope during diagnosis. Also, physicians' experience also matter in this regard. Diagnosis in early stages have some trouble also with traditional diagnosis. We want to build a framework that can be easily used by doctors and medical staff. We want to help medical field equipped with modern knowledge of modern tools and knowledge of diagnosis uh, to develop a model that enables system to work more efficiently in diagnosing patients at early stages. Provide machine learning framework for modernizing patients' medical checkup. Here is a related work which have been done in past few years. This paper was published in 2009 and the work was on wheezing sound. This scientist used a feature extraction technique, spectral projection and ANN, artificial neural network, and its application completely based on wheeze detection. Another paper was published in 2014, which also in which he worked also on wheezing sound. He used feature extraction technique, PSD based on Welk method and SVM, and its application is based on abnormal breathing sounds. Furthermore, researchers includes spirometer vibration response image, VRI, piezoelectric sensor, and air-coupled microphone. These are some of the devices which were used to properly assess the attributes of breathing sound. Another scientist compared three quartile frequencies in the global wavelet spectrum in 2008 to inquire at the seriousness of respiratory distress in COPD patients. Other studies shows five different subtle features to recognize three types of lung sounds: normal, wheezing, and crackle. Here is the methodology to our project. Uh, First process is data acquisition, in which a voice recording, we gather voice recording from data from web, and voice recording have also clinical record and having a physician opinion. Other step is data preprocessing, in which we import data into our software and we process the data through DSP, digital signal processing, in which we use bandpass filtering to filter the data. Furthermore, we go to the segmentation, in which we divide our data into separate equal chunks. Every chunk reveals the source property. Then the feature extraction techniques we have used statistical features and melt frequency substral coefficient. Statistical feature contains standard deviation, median, and mean. Then we go to training, in which we use machine learning technique, a linear algorithm, and then we further move toward testing. The first part of our project is data acquisition. The first process is data acquisition. Lung sounds of healthy and unhealthy persons are to be gathered. We have to collect data from hospitals or Labels of lung sound will be quite time consuming and reliable. If we want to get a reliable and authentic data set, we can take it from web. We took some of the data from Kaggle and some of the data from Mendeley. We took about 920 files from Kaggle and 130 files from Mendeley dataset. These were a reliable and authentic data set all over the web. Data, the data we took has been recorded with 4 digital stethoscope, that is Meditron, LitC2SC, 3M Litman, and AKG. Second step is data pre-processing, in which we import test signal and analyze it over the sampling frequency of 44.1 kilohertz, having a bandwidth of 50 hertz to 2.5 kilohertz. We filter the data using Butterworth bandpass filter over 100 hertz to 1 kilohertz frequency. We have removed voice, noise. Third process is segmentation. We use time series segmentation. The duration of each signals is varies from 15 seconds to 20 seconds. Every segment inherits the source property, as I discussed before. After segmentation, 5-second signal were extracted. We have used Python library for segmentation. Feature extraction. We have used MFCC, melt frequency substral coefficient, and other statistical features such as mean, RMS mean, standard deviation, RMS standard deviation, median. We have used Python libraries and method for feature extraction. After feature extraction, a CSV file have generated and we allocate the labels.
Let's come to see the features that we have extracted. This is the SNS plot of features in which we can see that the boundaries of mm, the boundaries of different features. If we see that there is a clear boundary between two features, so the features would have some importance. Like here, we can see that the features like standard deviation, uh, they have a clear boundary. So these features we can say are of some importance. So let's come to the classifications. The model we have used are SVM, logistic regression, KNN, random forest, and decision tree. Now, as we are using uh, the methodology that we would be uh, seeing, or we would be analyzing different models before feature selection and after feature selection. So for that, what we are doing, we are doing the feature selection technique. So for this technique, we have used L2 regularization. Uh, After L2 regularization, we have selected 8 features that are of importance out of all the 30 features. Okay, let's discuss the results or the testing accuracies of the all the models. So as we can see that the testing accuracies of the models before feature selection are approximately, or we can see that in random forest and decision tree it reaches to 100, which is an ideal case, and it looks in machine learning technique, if we get 100% result, so it creates some biasness, or it looks that it is an unpractical thing. So let's see the precision recall and F1 scores of our models. Here we can clearly see that the these scores of the model before feature selection are approximately equal to 100. So if we see the the scores are looking practical in the models or in the methods after feature selection. But out of all these, we can see that the SVM model gives constant result. We can clearly see that the F1 score is 93.81, and after feature selection it reaches 93.63. So it is a very negligible difference. The accuracies of decision tree, random forest, KNN, and logistic regression have shown a reasonable difference. The SVM classifiers accuracies have shown the difference but comparatively low. The F1 score of decision tree, random forest, KNN, and logistic regression have shown a reasonable difference too. The F1 score of SVM look like it do not exhibit some reasonable change. So the future work could be, alongside this work, this algorithm can be used in a variable system to help doctors investigate lung disease. This work can be further updated as this is only about the two levels, that is unhealthy and healthy. We can uh, increase it to the levels like COPD, UTRI, bronchitis, etc. So these are the references of related work that already some of them we have discussed. These are the links of the data set that we have gathered.
Thank you so much.
And final, thank you so much.